This lesson is about trig transformations. Let's jump down to the interactive panel here. But I want to explain something before we start. So the previous lessons were about our trig functions, so sine of x, and what happens when we graph it and we look at what happens over time, okay? What we're going to do now is look at the different ways we can transform this, because a lot of things in real life follow this pattern where it will kind of oscillate between 0 and 1 and -1. Maybe it's not 1 and -1, maybe it's between 2 and -2. And maybe it doesn't do it at this certain speed, maybe it goes a bit faster than that. So maybe it goes up to 2 and then quickly down to -2 and then up to 2 and quickly down to -2. Or maybe it moves upwards by 3, or maybe we can also shift it left and right if I just minus something like that. And now it's kind of moved a little bit off center. Maybe you can notice that. And this is all the same kind of theory as when we had our parabola that we've learned about, where some things in life follow this kind of pattern, especially if you turn this upside down and maybe move it up a little bit. This is what happens when you throw like a ball, for example. If you throw a ball into the air, it goes up and then it kind of pauses for a moment at the top and then it goes shoo when it comes back down, and then it obviously maybe bounces if you don't catch it. So, and we've looked at transformation of these too. So what if we times it by something, then it gets thinner? And what if we kind of divide it, or we times it by like a fraction like that, and we makes it get, maybe like fatter. And we can also shift it left and right and up and down. So we can make this -5 and now we've moved it down, okay? It's all the exact same things happening that we're about to talk about here, but we're just doing it with trig graphs now. So, what we want to think about really clearly here, so you know how on a graph, we have an x-axis and a y-axis. Let me clear this one up. We have an x-axis and a y-axis. And we want to really, really, really separate the two, especially when it comes to trig graphs, because they can be particularly confusing. So think about how y, if we have a graph, even just like 3x, think about x as the input, okay? And so if I input 1, so if x is 1, then 1 is here. And then to get y, which would be the output, I have to times x by 3. And 3 times 1 is 3, and so y should be 3, and that's there. So that's why we have that coordinate, which is 1, 3. Let's pick another number. What about if x was 4? Okay, so if x equals 4, 3 times 4 gives us an output of 12, and so we should see a 12 here, yep. And so we have the 4 goes in and a 12 comes out. Okay, this is super important for what we're going to talk about. So looking back over here at what happens with a sine function, what do we input into the sine function? Well, at once it's like x in here, and x, usually we might use theta. So we have sine of theta, and theta is the angle. Okay, so I can click and drag this, and x basically is this angle here. And then sine, if we remember back to our unit circle stuff, sine is, we can represent that by the opposite side here of the triangle that's made. Okay, and so the input is this angle in radians. And so if we go over to here, we have pi on 2 radians. No, sorry, we have pi. I was thinking it's a half circle, but we have pi radians, so about 3.14. And that's what goes in, and then we do sine, and what comes out is a 0, because when we do the sine of it, we can represent that by the vertical side here. So if I drag that back up, the vertical side, but as we get up to pi there, it goes down to 0. Okay, so input is the angle, output we can represent by how high this purple line is, like how big that part of the triangle is. Okay, I know I'm really, really, really over-explaining it, but it's about to get a little bit trickier. So what I want to look at first is, we can look at this one first, doesn't really matter, I don't think. So what happens when we do transformations to the input, okay? So I will quickly show you what this third panel is, because it shows the full equation that we're going to be looking at. So down here, this is what we can do. These are all the different transformations we can do to a sine function. So I'll type it out for us. Let's clear all these. X, X, X. Okay, y equals, and then we have our sine x, but these are the transformations we can do to it. A out the front, so we're going to times by something out the front. We can also do, what's the one on the inside called? B. Oh, great. We can also times by b here. We can also add k, so we can add something to the end. And we can also, like plus or minus, we'll say minus, and you'll see why we do that later, minus something with h. And then to keep this simpler, we can put the x in brackets. Okay, so these are all the transformations we can do. And let's have a quick look at what happens. If I tweak this one, it's going to stretch it up and down. If I tweak this one, it's going to stretch it left and right, like that. If I tweak this one, it's going to move it left and right. And if I tweak this one, it's going to move it up and down. Okay, so that's what we're going to be looking at. So if we look at the B here, and the B is when we're timesing, basically we're timesing the input by something. Okay, let me turn, I'll show you the B down here. So the B is down there. That's when we're timesing this input, the stuff that goes into the sine, we're timesing by something. I'm going to hide this for now. So ignore the H, ignore everything else, just looking at this B value here. If we change this to 2, what that means is we're timesing the input by 2, okay? And so if we have an input of 0 here, so if this angle is 0, then we move it up to like halfway, so like 45 degrees or pi on 4, pi on 4 radians. Okay, so a quarter of pi. What happens over here? So this is the input that's actually been transformed. So this is this angle here times 2. And so we actually end up there. And what about when we move to the quarter of the circle, so pi on 2? Well, that's halfway to pi, and then times that by 2 over here, and we end up with the full pi. And then if we keep going around to pi, then this other one has gone all the way around to 2 pi. Okay, pretty straightforward. So what if I times it by 4? And then we start again back from here. So this time when I only go to pi on 4, I've gone a quarter away the pi, and this one goes all the way around to pi. Okay, it's obviously a little bit off because the numbers are like slightly rounded. But you see what I'm doing. Maybe I can move it slightly. No, it's hard to get it exactly on. But you can see what's happening, right? So this input angle is only pi on 4, and this output angle, the input angle is pi on 4, and then we times it by 4, and so kind of our new input angle is pi, okay? And then if I move up to pi on 2, this one has gone 4 of those, so 1, 2, 3, 4, and it goes all the way around to, if I can get it exactly on, hopefully. Yeah. Sort of like that. Goes all the way around to 2 pi. Okay? And then I can times it by maybe a fraction, like 1 over 2, so only halfway. So this time if my actual input is pi on 2, my like transformed input is halved, and we only have pi on 4, so it goes half of that distance. If I go into pi, this one's only pi on 2. If I keep going around to 2 pi, this one that's been transformed is only half. Okay? Cool. We can do a quick animation here if I clear everything, and then let's make it 3, and then we can press play here, and it's just going to automatically increase it. Let's increase the speed. Okay, so see this one's moving pretty normally. Okay, just going up. This one, what's happening here? It's going a lot faster. Okay, so basically instead of our input angle moving at the speed that it normally would, when we times it by 3, it moves 3 times as fast. Okay, pretty straightforward, but it's worth breaking it down really, really simple, because once we start getting to the question, it gets a little trickier. Okay, so that's B. You're just timesing the input. Let's put it back to 1, because when we times it by 1, nothing happens. Let's look at H now. So H. What is H doing? So if we look at our full equation here, H is down here and it's minusing from X. Okay, so let's try something. Let's make it, it's good to keep it in radians. Let's make it pi on 4. Okay, so when we have an input of pi on 2, over here, instead of having pi on 2, which is all the way up here, it just minuses and it goes back to pi on 4. And then if we go all the way around to pi, just pi, for our like actual angle, our transformed angle is gone back by pi on 4. So it's actually 3 pi on 4. Okay, and then all the way around to 3 pi on 2. And this one is 1, 2, 3, 4, 5. So 5 pi on 4. But you see how it's just lagging behind? So if we press play and watch the animation go, I'll increase the speed a little bit. See how it's this kind of following at the same speed? They're both going like a medium speed. But this one over here is just lagging behind by pi on 4. Okay, cool. Let's pause that. Let's try something else. Like what about pi on 3? Okay, and so same thing. Let's go back to pi, and instead of pi, we go back by pi on 3 because we're minusing pi on 3, and then we get left with that. Okay, pretty straightforward, right? Cool. If we want to do the opposite, we can make this negative, because that way we're minusing the minus. We'll probably talk about why we leave it as a default minus instead of, see how this one here is a plus k, the h is minus. We'll talk about that at some point. But anyway, so if we do want to add onto the angle instead, we can just make h a negative value. Then the two negatives will cancel and make it positive. So let's hide that again. And now look what's happening. If we're at pi, with our actual angle, the transformed angle has an extra pi on 3. And so it goes up to, 4 pi on 3. Cool. I think that's enough with that one. Let's put it back to its default, which would be 0, because adding or minusing 0. Oh, let me clear this. And adding or minusing 0 is nothing actually happens. So that's B and H. We're going to talk about A and K, but not quite yet. There's some practice questions here that focus just on the B and the H part, so you can get the hang of that first. So do those practice questions, and after you finish them, you can go down here, which is where we're going to talk about the A and the K, which is in this section here. And after you finish the A and the K, it has its own practice questions down here. So do the practice questions here first, then jump down to this next section.